Hello, this is the second of two videos on inverse variation, as shown here in the syllabus. Two quantities are inversely proportional if, when one is multiplied by a constant, then the other is divided by the same constant. If the quantities y and x to the power of n are inversely proportional, then we write y is proportional to 1 over x to the power of n. This leads to the equation y equals k over x to the power of n, where k is a constant, called the constant of proportionality. In general, when y is graphed against x, the graph has the shape shown. Both the y-axis and the x-axis are asymptotes of the graph, so the graph does not have a y-intercept or an x-intercept. One pair of coordinates is needed to find the value of k, the constant of proportionality. Substituting these coordinates into the equation and solving for k will give the value of the constant. In part A of this question, we're asked to find the resistance in the wire when its diameter is 0.3 centimeters. If we begin by defining variables, letting r be the resistance and d be the diameter of the wire, then state the variation. And since the resistance in the wire is inversely proportional to the square of the diameter, then this leads to the equation r equals k over d squared. Then we can substitute in the given values, replacing r with 0.24 and d with 0.44. Solving the equation for k gives the value shown. We could have also found k by using solver on the calculator, as shown. Next, stating the equation, replacing k with its value. Then substitute in the new value, a diameter d equal to 0.3. Performing the calculation gives the value of r shown. So the resistance is 0.516 ohms when the diameter is 0.3 centimeters, given correct to 3 significant figures. In part B, to find the diameter of the wire when the resistance is 0.45 ohms, if we begin by stating the equation and substituting in the new value of the resistance, replacing r with 0.45, rearranging the equation, given the value of d shown. Alternatively, you could use solver on the calculator to solve the equation, as shown. So the diameter is 0.321 centimeters when the resistance is 0.45 ohms, correct to 3 significant figures. Once you've found the constant of proportionality, another way of solving this problem is to draw the graph. From the main menu, select Graph. Type the equation into y1, pressing the fraction button into the numerator, inputting 0.046464, and then scrolling down to get to the denominator, pressing the x variable button to represent d, and then pressing the square button. Press Execute to enter the equation. Press Shift F3, View Window, to set up a suitable window. I'm going to set negative 0.1 for x min, 1 for x max, with a scale of 0.2, and for y, I'm going to set negative 0.2 for y min, 1 for y max, and again a scale of 0.2. Then press Execute and F6 to draw the graph of the equation. So in part A, to find the resistance, on the calculator this is a Y calculation. Press F5, G-solve, F6 to get to the second page of tabs, and F1 for a Y calculation. Enter the value of X, which is representing the diameter, so that's 0.3, and press Execute. Write down the value of Y, which is representing the resistance, and you can see that we get the same value that we had before. In part B, to find the diameter, on the calculator this is an X calculation. Press F5, G-solve, F6 to get to the second page of tabs, and F2 for an X calculation. Enter a Y value of 0.45 for the resistance and press Execute. Write down the value of X, which is representing the diameter. As before, the diameter is 0.321 centimeters when the resistance is 0.45 ohms, correct to 3 significant figures.